welcome to the 5th video tutorial for Intro to Dragon. This video will show you how to generate and read multi-group macroscopic cross-sections using Dragon. To do this, we are going to be using the Mac module, which is responsible for creating a macroscopic library, different from the microscopic libraries that we were creating using the lib module in earlier examples. When the Mac module is creating the macroscopic library, it can either take the data as a direct input from the input deck, or use the cross-sections and mixture information provided in a microscopic library. To take the data from an existing microlibrary, just call on the Mac module using the data structure that is holding the data from the lib module. Also, we need to pass the Mac module the same data structure. The macroscopic cross-sections can be seen if the ASM module has an edit level of 3. In the results, you will be able to see the macroscopic cross-sections for all of the energy groups that are being considered. After running the input deck and looking through the results, we can see here in the ASM module all of the different macroscopic cross-sections as well as the volumes for each of the mixtures. I am now going to edit the single fuel pin input deck we made together to use a macroscopic library without the use of a microscopic library. To create a macroscopic cross-section in an input deck not using the lib module, the Mac module must be used. First, you call upon the Mac module along with the data structure that will hold the data. Then, the ngro keyword will be used to enter the number of energy groups to be considered in the cross-section. In this case, we are going to use 2 energy groups. Next, we are going to state the number of mixtures using the nmix tag. We will be using 2 mixtures in this example. Then, we will put the NIFI keyword to denote the number of fissile isotopes present. In this case, there will be 1. Next, we will put read input, meaning that it will read the data from the input deck. For mix 1, the first thing we put is total. Then we write the cross sections in the unit of centimeters to the power of -1. We need to put 2 cross sections, 1 for each energy group present. Next, using the scat keyword, we will enter the scattering cross-sections for each of the energy groups. First, we enter how many cross-sections we are entering, then we enter how many cross-sections there are total. These cross-sections will be ordered from lowest energy group to highest energy group. The first energy group has 1 scattering cross-section and the second energy group has 2 scattering cross-sections. Next, we will use the NUSIGF keyword. The values that follow are the fission cross-sections multiplied by the average number of neutrons released per fission for each energy group. Then, the CHI keyword is used to denote the fission spectrum for the mixture. Next, we will enter the data for the second mixture. We do not need the NUSIGF and CHI keywords for mix 2 because there are no fissile isotopes present in this mixture. Before we save this input deck, we need to make sure to delete the SHI module and the EVO module, as we no longer have the appropriate data to use these modules. We will also delete the output files of these modules and the COND keyword out of the EDI module. After making those changes, we save the file and run the input deck. Now, looking through the output file, in the results for the ASM module, we can see the macroscopic cross-sections for the two energy groups and the volumes for each of the mixtures. One thing I recommend before the end of this video is to look at the example in section 4.1 of scattering cross-sections, as the format for data entry can get quite complicated. That will conclude this video tutorial.